All right, sixth grade. Here's chapter 3, review number 2. And number 1 says how many numbers on the list are greater than 2/5. So let's make 2/5 a decimal. Remember, to go from fraction to decimal, we divide top divided by bottom. The fraction falls over. Remember, the top number goes inside the division bracket and the bottom number goes outside. You place your decimal after the last digit that you see. So after the 2 is the decimal, and we can add placeholder zeros after that decimal, of course. The decimal comes straight up into our quotient, into our answer. We know that 5 cannot go into 2, right? It's too big, goes in 0 times. But 5 goes into 20 exactly 4 times. And so 4 times 5 is 20. We subtract and get 0. So in fact, 2/5 is the same thing as 0.4. Okay, or we could say 0.40. So let's keep that in mind. And as you can see, A and E are already in decimal form. And so in option A, you have 4/10, or if we add a placeholder 0 here, it's 0.40. So is option A, is 0.40 greater than 0.40? No, right? It's not greater than, it's equal to. So option A is out. What about option E? Is 0.39, is that greater than 0.40? No, right? That's less than. So option E is also out. Okay, let's look at option F. It's also decimal form. It's a repeating decimal, 0.4 repeating. And so this would be 0.44444 forever and ever and ever, right? That's what the repeating tells us. So if it's 0.44, is that bigger than 0.40? Yes, right? Because it's 44 hundredths instead of 40 hundredths. And so option F, yes, is greater than. Okay, we have 3 options left we need to check. We need to check B, C, and D. So they're all fractions. The strategy here is to make the fractions decimals and then see, is it bigger than 40 hundredths or not? Okay, so I will leave that to you to change the fractions to decimals. Take top divided by bottom. So this one would be 2 divided by 7. There's your decimal, add placeholder zeros and divide. This would be 4 divided by 11. There's your decimal, add placeholder zeros. This one would be 5 divided by 9. Okay, so be sure you set it up correctly. And you're looking for how many of these numbers, we already found one of them, how many of these numbers are greater than 2/5 or 40 hundredths. Number 2, which set of rational numbers is correctly ordered from least to greatest? So with the smallest number listed first. As you can see, every number in the list is a negative number. So let's draw a vertical number line to help us sort of figure this out. Okay, so I have negative 1.70. Let's put negative 1.7 or negative 1.70 right there. Okay, now if I keep going down, what number is below negative 1.70? Let's just count by 2. So let's say this is negative 0.172. Below that, if I'm counting by, or not twos, but counting by hundredths, negative 1.74. Then I would have negative 1.76. Then negative 1.78. Negative 1.80, negative 1.82, and so on, right? The numbers above negative 1.70 would be negative 1.68, and so on. Okay, so here's my number line. Now on my number line, if you are the smallest number on the number line, you would be further down on the number line. Okay, if you're higher up, then you're greater than the other numbers on the list. So out of these numbers, what's the smallest number in the list? It looks to me like the smallest number in the list is this number, negative 1.78. So that number needs to be listed first. So that would eliminate option B and C. Okay, option A has negative 1.78 listed first. That is the smallest number in the list because it's furthest down on the number line. Okay, now what's the next smallest number? The next smallest number is this number, negative 1.76. 76. Okay, so those are still in contention, A and D. The next smallest number would be negative 1.74. I don't see that number in the list. So the next smallest number is negative 1.72. Okay, so that would be here. Nope, D is out. Okay, so the greatest number in the list is negative 1.70. That should be listed last. And so as you can see, option A is the correctly ordered list from smallest to greatest. So when ordering negative numbers, I would strongly encourage you, like I did, draw a vertical number line so that you can tell which number is smallest because it's furthest down on the number line, and which number is bigger because it's higher up on the number line. Number 3, what is the location of the point labeled A in the number line below? So here's the number line, here's A. Okay, so here's 0. We go negative 1, negative 2, negative 3, negative 4, negative 5. Okay, point A is a little past negative 2. So if this is 0, this would be negative 1. This is like negative 1.5 because it's halfway between negative 1 and negative 2. Here's negative 2, and I'm a little past negative 2. So this would be, what would be a little past negative 2? Not that one, not that one, not that one, not that one. Okay, these two options would be in contention for being a possible answer. Okay, now negative 2.7, this one's going to be almost to negative 3. So that would be more like in this area right here. Okay, so I'm not quite to negative 2.7, so this must be negative 2.2, which of course is a little past negative 2, so this is the correct answer. Number 4, which number has the greatest absolute value? Now, by now, we should know that absolute value is a number's distance from 0. We've been talking about that since chapter 1. So how far is 0.38 away from 0? It's 0.38 away from 0, 0.38 units. How far is negative 0.9 away from 0? Well, it's 9/10 or 0.9 away from 0. So as of right now, B is further away from 0 than C is, so C is out. Here's the fraction 2/9. So if I make this a decimal, I would have 2 divided by 9, and I would figure out that this is, in fact, the decimal 0.2 repeating. Okay, 0.2 repeating. So how far is 0.2 repeating away from 0? Well, it's 0.22222 away from 0. So is that further from 0 than this one is? This is 9/10. This is about 2/10 from 0. No, right? That one's not further away from 0. Not further than this one is. So last one I have to check here is A. Negative 7/8. What is the absolute value of negative 7/8? You should say 7/8, right? It's 7/8 unit away from 0. So what is 7/8 as a decimal? I need to figure out 7 divided by 8 and see, is this number further away from 0 than this one is? That's what I need to figure out in number 4. Number 5, which statements about rational numbers is not correct? Okay, all whole numbers are also integers. Okay, so remember we have all the rational numbers. We have all the rational numbers, which are fractions and decimals. Okay, inside here we have the whole numbers, and integers. Inside there we have the integers. All right, so all whole numbers are also integers. So here's a whole number, let's say 15. Okay, this whole number 15, is it also an integer? So I'll put W here. Here's the whole numbers. Here's the integers. I'll put R for rational. Okay, you've seen this before, and last week we had a Venn diagram very similar to this. So a whole number 15, is it also an integer? Yes, it is. 0 is a whole number. That's true because it's actually the first whole number. All rational numbers are also whole numbers. So how about the rational number 0.1? That's a decimal. Is that 0.1 also a whole number? No, it's not. No, it's not. So that one's not correct. There are no negative integers. So how about negative 3? Is that a negative integer? Yes, it is. So this one, and this one are true. This one right here is the only one that is not true, and so that's what I should select, right? Because the question asked me which one is not correct, because there are all kinds of rational numbers that are not whole numbers. Number 6, Cooper wrote the numbers, all these mixed numbers, in the form A over B. So he's making the mixed numbers improper by using the C method. And so the question is, what is the greatest numerator that Carson wrote? So let's use the C method for 5 and a 7th. 7 times 5 is 35. 35 plus 1 is 36. So 36 over 7. That makes this one improper. 8 and 2/3. I would have, using the C method, I would have 3 times 8 is 24. 24 plus 2 is 26 over the original denominator of 3. 9 and a half, using the C method, I would go 2 times 9 is 18. 18 plus 1 is 19, all over the original denominator of 2. So 19 halves. And 2 and 2/5, I would have 5 times 2 is 10. 10 plus 2 is 12, all over the original denominator of 5. So what Cooper just did is use the C method to make all the mixed numbers improper. Now they are in the form A over B, or some integer over another integer. What is the greatest numerator that Carson wrote? So let's look at all the numerators, which of course are all the top numbers in the fractions. So all of these numbers. What is the greatest number in the numerator? So 36, 26, 19, or 12. Which one's the biggest? 36, right? So 36 is my answer. Number 7, write these numbers in the form A over B from greatest to least. So let's first figure out what these numbers are in order from least to greatest by making them decimals. So I have negative 2.3. Then negative 2.5 would be negative 2 point, whatever 1/2 is. What is 1/2 as a decimal? It's 0.5, right? Negative 2.5. All right, so I have negative 2 1/3. That's going to be negative 2 point, whatever 1/3 is as a decimal. If I make 1/3 a decimal, I would find out that's 3.3 repeating. Then I have negative 2 and 2/5. So that's negative 2 point, whatever 2/5 is as a decimal. And so again, I must easily be able to make a fraction a decimal. How do I do that? I divide, right? Top divided by bottom. And in fact, we did that in number 1. We made 2/5 a decimal. We found it was 0.4 or 0.40. Okay, so here's all my decimals. I'm going to draw a vertical number line because I'm ordering negative numbers, and I think a vertical number line is helpful. All right, so let me say this is negative 2. This would be, if I go down by 1/10, that's negative 2.1, negative 2.2, negative 2.3, negative 2.4, and negative 2.5. Okay, and I could keep going if I needed to. Now, out of this list, what is the smallest number in the list? So out of these numbers, negative 2.3, negative 2.5, negative 2.3 repeating, and negative 2.4, what is the smallest one? So the number furthest down on the number line, that will be this one, right? Negative 2.5. And so I know if I want the list in order from greatest to least, that this number, negative 2.5, should be the last number in the list. Now remember, this number is also negative 2.5. And by using the C method, if I use the C method over here, so negative 2.5, using the C method, 2 times 2 is 4, 4 plus 1 is 5. So this is the same as negative 5.5. So that number should be the last in the list because it is the smallest. It is the least. So by looking at my list here, which number has negative 5.5 as the last number, as the least number? Well, option B does and option D does. So that eliminates option C, that eliminates option A. All right, so that's pretty nice because I'm down just to 2 options now. So what would be the next smallest number? Well, the next smallest number, if I've already used this one, how about negative 2.4? Right, that's the second to last on this number line. So negative 2.4, that came from this number, which was negative 2 and 2/5. So if I use the C method to make this improper, 5 times 2 is 10. 10 plus 2 is 12. So negative 12/5 should be the second to last number in the list because it is the second smallest number. So here's option B. I have negative 5 halves as the smallest number and negative 12/5 as the second smallest. So it looks like option B would be my answer, right? I could keep going to figure out that the greatest number is in fact negative 2.3, and negative 2.3 is negative 2 3/10. If If I use the C method to make it improper, 10 times 2 is 20, 20 plus 3 is 23. So as you can see, negative 23 tenths is listed first because it is the greatest number. So here's the greatest number, and then you go down, right? These numbers get smaller. Negative 23 tenths, negative 7 thirds, negative 12 fifths, negative 5 halves. So this list right here, option B, is ordered from greatest to least. So again, make your mixed numbers into decimals. Draw your decimals on a vertical number line to see which one's the greatest, which one's the biggest, and then you have to use the C method to make them improper fractions. Number 8, which points the number line have absolute value less than 2? Remember, absolute value is a number's distance from 0. So I know from here in and from here in, everything inside of these blue lines is going to have an absolute value less than 2 because it's going to be less than 2 away from 0. So like the point C, it's less than 2 away from 0, right? And so is B. B is also less than 2 away from 0. But all the points outside of these blue lines that I drew are going to have an absolute value greater than 2. Like here's A. Point A, well, it's at negative 3 point something. So its absolute value will be 3 something. So, of course, that's bigger than 2. D and E, they're also, like D is going to be at 2.2, say, and so its absolute value will be like 2.2. And E is at, let's say, 3.3. And so its absolute value would be 3.3. And so what are the only points that have an absolute value less than 2? It would be these points right here we talked about, B and C. B, which points in the number line have absolute value less than 2? B and C. Is that an option? No, it's not. So I'm going to go back and change this, all right? But look for the option B and C. Number 9, on which day or days was the temperature greater than negative 1.5? So we're talking about temperature. Anytime we talk about temperature, I've always taught you to draw a vertical number line. Okay, so let's say this is negative 1. And let's go down by 2 tenths. So negative 1.2, negative 1.4, negative 1.6, negative 1.8, and then I have negative 2.0 or negative 2. So which day or days was the temperature greater than negative 1.5? So negative 1.5 would be right here, right? In between negative 1.4 and negative 1.6. So I want the days the temperature is greater than that, so higher up on the number line. So would negative 1.2 be greater than? Yes, it would. Negative 2 is down here. Is that greater than negative 1.5? No, it's not. Negative 1.8 is right here. Is that greater than negative 1.5? No, it's not. What about negative 1.4? Is that greater than negative 1.5? Yes, it is. So it looks like I need Monday and I need Thursday. Monday and Thursday, this option right here. Last one, number 10. Which number has the greatest absolute value? So you want the number that is furthest from 0. I would make all of these decimals and then figure out the absolute value, the number that is furthest from 0. Okay, I'm going to add a note here that says go back and fix your mistakes. I would like for you to go back and fix your mistakes. If you have any questions, email me.